In this video, we discuss the paper titled Minimal 3-Component SU2 Gadget for Polarization Optics, written by R. Simon and N. Mukunda. You can find the link of this paper below in this description. In this paper, three main identities are proved which involve quarter wave plates and half wave plates. The important one is third one, which is writing a SU2 matrix as a combined form of two quarter wave plates and a half wave plate. To prove these results, we need some basic knowledge. Let us proceed with it first. Consider a coordinate system with x1, x2, x3 axis. Assume that light beam propagates along x3 direction. A bright fringed plate with slow axis along x1 direction, which introduces a phase difference among the other components, which is written in a Jones matrix form, which has a diagonal elements, which is given in equation 1. If the slow axis makes an angle phi with x1 direction, then the Jones matrix will be written in the form of equation 2, which has a rotation matrix and its inverse to the front and back. So this nu of phi is given in equation 3, which has cos phi minus sin phi cos phi. These rotation matrices has some important properties. If you combine the two rotation matrices which is having two different angles, let's say phi 1 and phi 2, which gives another rotation matrix which has angle phi 1 plus phi 2. So the Jones matrix of a birefringent plate, when you expand it in a 2 cross 2 matrix form, you will get equation 4. Now we can define half wave plate and quarter wave plates. A half wave plate with slow axis along x1 direction is defined as Jones matrix, which has eta as pi and phi as 0. So you will get I sigma 3, which is given in equation 5. A half wave plate with slow axis making an angle phi with x1 axis, you just have to attach rotational matrices and its inverse to the front and back. So you will get the equation 6, which is the half wave plate in a general form. So you can expand that half wave plate in a 2 cross 2 matrix form. So you will get nu of 2 phi I sigma 3, or you can write it as also I sigma 3 nu of minus 2 phi. So h of phi in general form, it will be nu of 2 phi h naught or h naught nu of minus 2 phi. Now let us consider nu of 2 phi prime and h of phi. What is the result? When you expand this in a matrix form, you will end up with h of phi plus phi prime, which is equation 7. Now let us consider nu of 2 phi prime and h of phi. What you will end up with? So you will end up with h of phi plus phi prime. So now nu of 2 phi prime can also be written as h of phi plus phi prime, h of phi inverse. What is this h of phi inverse? This is nothing but h of phi plus or minus pi by 2. You can write it in a matrix form and check all these results. So if you consider nu of phi prime, h of phi, nu of phi prime, so you will end up with h of phi. So these are the important properties of half wave plates. We will use it later to prove the identities given in the paper. So a quarter wave plate with slow axis along x1 direction is defined by taking eta as pi by 2 and phi as 0. So you will end up with the 2 cross 2 matrix of this form given in equation 9. So a quarter wave plate with slow axis making an angle phi with x1 axis, you just have to attach the rotation matrix and its inverse to the front and the back. So we'll get a matrix form of equation 10. We need another one identity which is exponential I eta by 2 sigma 3, where sigma 3 is Pauli Z matrix, which is 1 0 0 minus 1. So you can write that matrix as nu of pi by 4 q naught, nu of eta by 2 q naught inverse, and nu of minus pi by 4. You can check with the matrix form. If you write it in a matrix form and multiply all these matrices, you will end up with the exponential I eta by 2 sigma 3. So we'll make use of all these identities, and now we find the results given in this paper. The first result is prove that q of phi h of phi prime is equal to h of phi prime q of 2 phi prime minus phi. So for that, let's take the left hand side, expand the q of phi as nu of phi q naught nu of minus phi, and h phi dash as h naught nu of minus 2 phi prime. So now you can combine nu of minus phi and h naught as h naught nu of phi. That is what is written in the next step. Then you can combine nu of phi and nu of minus 2 prime, because nu of alpha nu of beta is nu of alpha plus beta. This gives a combined form of the rotation matrix. Then let's introduce nu of phi minus 2 phi prime and nu of 2 phi prime minus phi, which is nothing but the identity. So the identity is written as R into R inverse, rotational matrix and its inverse. So we'll include a rotational matrix and its inverse in between h naught and q naught. And the first term is nu of phi. The second term, h naught nu of phi minus 2 phi prime, is written as, you can invert it and write it as nu of 2 phi prime minus phi h naught. And the last term is nothing but the quarter wave plate with slow axis making angle 2 phi prime minus phi with the x1 axis. So we can write this as q of 2 phi prime minus phi. So you can combine the next the first two rotational matrices and write it as nu of 2 phi prime and h naught q of 2 phi prime minus phi. So the first two you can write it as h of phi prime as per the identity, and the last one is q of 2 phi prime minus phi. This is the desired result what we have got. You can also similarly prove the equation 12 in the same way. The next identity is to show that h of alpha q of beta h of gamma as h of alpha minus beta plus gamma minus pi by 2 q of 2 gamma minus beta plus pi by 2. So let's take the left hand side, h alpha q beta and h gamma. Keep h alpha as it is. So expand the q beta as nu beta q naught nu of minus beta, and also h gamma as nu gamma h naught nu minus gamma. Now we can combine the nu of minus beta and nu of gamma and write it as nu of gamma minus beta. And then we can combine the right hand side h naught with nu of gamma minus beta, so which you can change in the form of h naught nu beta minus gamma. Now we know that we can combine the rotational matrices. The end two rotational matrices are combined, just adding the angles. So you will get h alpha nu beta q naught h naught nu of beta minus 2 gamma. Since q naught and h naught are they commute each other, you can write it as h naught q naught. Now we will introduce we'll write h naught q naught as, we can find the when you expand this, h naught q naught and nu of pi q of pi by 2 will get the same result. So now I will replace h naught q naught by nu of pi and q of pi by 2. So when you write it as nu of pi, you can combine with beta, and you can write it as h alpha nu of beta plus pi q of pi by 2 nu of beta minus 2 gamma. Now we have to introduce another rotational matrix and its inverse in place of identity between nu of beta plus pi and q of pi by 2. So when you introduce it, we will introduce nu of minus 2 gamma plus beta and nu of 2 gamma minus beta. So you can combine the rotational matrices and write it as nu of beta 2 beta plus pi minus 2 gamma, and the rightmost part is the quarter wave plate with rotational slow axis making an angle 2 gamma minus beta plus pi by 2 with the x1 axis, and the left hand side is just h alpha plus gamma minus pi by 2 minus beta. So this is the result of what we wanted to get. Now we have proved the two identities. The last one is to write the SU2 matrix as the as an expression which has two quarter wave plates and one half wave plate. So we know the identity of SU2 matrix. We can write it is in three rotational matrices along sigma 2, sigma 3 and sigma 2 again. And when you expand now with the first one as exponential minus I psi by 2 sigma 2, so this is nothing but the rotation matrix. And the last one will introduce identity operator and we will add an angle and take its inverse. Psi by 2 and minus psi by 2 is considered, and when you combine them, the two those are the rotation matrices. So at the end you will get nu of psi plus zeta by 2, and the first one is nu of psi by 2 and the nu of minus xi by 2. So here we have only the exponential I by 2 eta sigma 3. I have shown this one is expanded in the form of nu pi by 4 q naught nu eta by 2 q naught inverse nu minus pi by 4 nu minus psi by 2. So now you can combine the rotation matrices. So when you combine the rotation matrix, it's just the addition of the angles. So we'll end up with this identity. And now what we have to do is introduce the identity operator in between the q naught and nu eta by 2. So that identity operator is the rotation matrix and its inverse. The rotation matrix is nu psi by 2 plus pi by 4 and its inverse. So when you introduce that, the first three terms will give the quarter wave plate making an angle psi by 2 plus pi by 4 with slow axis, and the nu eta by 2 rotation matrix, and the next one is q psi by 2 minus pi by 4, and the last is 1 rotation matrix. These now the rotation matrices we can use the identity to write in terms of the half wave plates that I showed earlier. And when you write it in terms of two half wave plate, we will get eta naught is the arbitrary value you can choose because it doesn't matter for it, and zeta naught is also an arbitrary value to choose. So when you choose it as in such a way that eta naught is psi by 2 plus pi by 4, zeta naught is psi by 2 minus pi by 4, so we can write in terms of 4 quarter wave half wave plate and 2 quarter wave plates. Now the same angle quarter wave plate and the half wave plate which is commutable, so you can write the h and q as q and h. So it will combine with the inverse and all h psi by 2 minus pi by 4 h psi by 2 plus pi by 4 cancel, and you will have only q psi by 2 minus pi by 4. So now we have an identity which has two quarter wave plates and two half wave plate, h alpha, q beta, h gamma. So combined to give an identity which has only one half plate and one quarter wave plate. So when you combine h, q and h, you will get h, q with the respective angles. This is the identity we obtain with the SU2 matrix. So now this concludes that every SU2 transformation can be realized using three plates, two quarter wave plates and one half wave plate. Thank you.